Hello everyone. In the last lecture, we discussed about image classification. In this class, we will see how we can implement image classification solutions using Python libraries, and we will follow two approaches for the same. First, we will see how we can implement the same using the traditional machine learning approach, and then we will see how we can utilize deep learning approaches like CNN in order to get better results for image classification tasks. Let's start. If you remember in the previous lecture, we discussed broadly what do we mean by image classification and how it is different from the very traditional classification approach where data is organized into a tabular format. And then there are two ways of doing the classification of images. One is the traditional approach and another one is the CNN based deep learning approach. So we already discussed in the last lecture that in the traditional approach, we take this image classification data set. The corresponding class is also given to us for a given image. And then first we try to convert that into the standard classification format. Once we do that and we get data like this, then we can apply any standard approach, let's say the traditional neural networks, to resolve this problem. However, in the era of deep learning, this approach has changed, and now we take only the image and we put that into the deep learning model. In the traditional way, however, given an image, we identify the number of pixels in the image, treat each pixel as an independent variable. So we have discussed already in the last class that we'll have 400 pixels in this specific case, and we will arrange our data like this. However, if we talk about deep learning based CNN approach, CNN stands for convolutional neural network, then it comprises of several steps, different types of layers. They are arranged in a very specific way in order to get better results. So their arrangement becomes really important, and coming up with the right configuration and right architecture of a neural network is often not very straightforward. However, in the last class, we tried to discuss what do we mean by a convolutional layer, max pooling layer, batch normalization, dropout. This whole combination of 4 layers is called the first convolutional block. Then you can have many convolutional blocks in your architecture. Finally, we flat them out to represent them as a single vector. Then we have the fully connected layer, and finally, we might have the output. In this specific case, there are 8 classes. So this is the CNN based approach. The benefit is that given the data set, we need not to first convert that into the structured format. This architecture consider the input image as it is and then does the internal processing. We tried to discuss in the last lecture how it is done. First, the low level features are identified. They are combined together to generate mid-level features. Then mid-level features are combined to generate further high-level features and concepts. And this is how the classification is carried out. Before we go into the implementation part of both the approaches, let's discuss the problem statement for today. Today we will try to do a task called handwritten digit recognition, where we have images like this which are written by humans and their corresponding class is also given. Now the objective here is that given a new image of a digit written by a human, let's say it is a 6, can our system, given the existing training data set, can our system identify what this image is, whether it is a 6 or 7 or any other digit? We will use a very famous data set for the same called MNIST image data set for handwritten digits. It has total 10 different digits related pictures or images starting from 0 to n. So it has, this data set has lots of images of handwritten zeros because different people write 0 or other digits in fact in different ways. Lots of images of 1, lots of images of 2, and similarly till 9. As you can guess, the total number of classes here are 10 starting from 0 to 9. So this problem actually is a multi-class image classification problem. Let's explore how we can implement this specific digit recognition problem with the help of images by applying both the approaches, the traditional approach and then the deep learning based CNN approach. Let's discuss the coding part now. Now let's see how we can implement the image classification problem. To be specific, the handwritten digit recognition problem with both the approaches. Let's first start with the traditional approach. So as you can see on your screen, I have already mounted the drive. Let's load the necessary libraries. Here we will implement our problem using the multilayer perceptron classifier, and we have other relevant libraries also. So we have uploaded the libraries. Next step is to load the data from the drive. So I have already divided the data into different training and testing set. The data which is available through MNIST is in both the forms. When I say both the forms, it means it is already there in the image form. Also, it is available in the pixel values form where the image is stretched out as a single vector, right? And the corresponding digit is there. So this data set is of the pixel value. It does not contain images right now. It contains the corresponding pixel values and has already been flattened out into the form of a vector. We will see that soon. So let me upload the training data as well as testing data. Now once the training and testing data is uploaded, then let's check what is the size of the training data set and testing data set. So as you can see that there are a total 60,000 images or the pixel values corresponding to 60,000 images in the training data set and 10,000 in the testing data set. And as you can check that the number of columns are 285 because this data set contains images of the resolution 28 by 28. So if we take the 28 by 28 matrix of pixels and identify how many different pixels are there, they are going to be 28 times 28, that is 784, plus one extra column for the corresponding digit. That's why we have a total number of 785 columns. Let's try to see a few rows here from the training data set. So you can see that starting from column 0 to column 783, it means a total of 784 columns. This data set contains the corresponding pixel values. So we are looking at a first few pixel values and a last few of them. That's why you see all the values are as zeros. But if you'll see the whole row corresponding to one image, you will find other values as well. So this first row represents first image, second row represents second image, its corresponding pixel values, and so on. The last column you can see is digit, which tells us these pixel values, let's say, represent what digit, right? So this image corresponds to a digit 5. The next row here corresponds to digit 0, then 4, and so on. So each row once again is an image that has been stretched out as one vector of pixel values. Similarly, you will find similar structure in testing data set as well. Now let's move forward, and we have to convert the given data into X and Y pair. For that, we will remove the digit column from our set of independent variables x, and we will keep the last column digit in the column of the dependent variable, that is y, and we will do the same for the testing data as well. So once this is done, now if we'll see once again the shape of the matrix corresponding to independent variables only, you will see now the number of columns are 784. Earlier they were 785 because we have removed the column corresponding to the dependent variable, yes, the digit. Now we can set up a classifier. In this specific case, we are using multi-layer perceptron classifier, and we can set its parameters also. Since image classification usually is a tedious task, even when we are using the traditional networks, we try to use more hidden layers or more complex hidden layers with lots of neurons within them. In this specific case, I have considered two hidden layers, each having 100 number of neurons. So you can imagine that the input layer has 784 pixel values. Then the first layer has 100 neurons, and all of the input values, 784 input neurons, they are connected with the hidden layer neurons. And then once again we have one more hidden layer, and finally we have the output layer, and here output layer also has 10 neurons. Each neuron represents one digit. So you can imagine that even by the traditional way, this structure is quite complex. The number of epochs or maximum number of iterations here are 500. The activation function I have considered is 10H. The solver or the optimization algorithm we are using is SGD, stochastic gradient descent. Certain learning rate value is there, and some random state value is also there. So we can create this model, and then we will fit the model. Now when we fit the model, we will pass the training data, the set of the independent variables, which is x, and the column of dependent variables, that is y. Now the processing will take some time, so I will not run here right now. I have already ran it earlier. So let's see the results of this model. Otherwise, if I run here, it will take a lot of time. So to avoid much delay in that, I'm skipping this part and directly going into the results part. But it has created the MLP classifier with the parameter values that we have supplied. Later on, we can use the test set and pass it to our model to predict the corresponding y values related to test set. And then knowing the actual test values and the predicted test values, we can calculate the accuracy. For this specific model of multi-layer perceptron, we got the accuracy of 97% around, so 97.25%. We can also calculate other performance measures that we have discussed earlier, such as confusion matrix, precision score, recall score, FN score, and other things, and we can plot them also. So when we try to calculate these values, we get this confusion matrix, which represents the confusion matrix related to 10 different columns now, 10 different classes now, starting from 0 to 9. And then we can also calculate the precision and recall and FN score values, the weighted version of precision and recall and FN score, and we can see the whole classification report as well. So in short, we can say that when we supplied the data which is already processed, images are already processed in the form of the vector as a row vector, and supply that to the MLP classifier with two hidden layers, then we got 97.5 accuracy. I want you to remember this number, the accuracy, using traditional way, because when we will do the same for the deep learning way, using the convolutional neural network model, then we can compare the results of that model, deep learning model, with the this traditional model. So 97.5 percent was the accuracy. Now let's move to the convolutional neural network part. Here we use more advanced frameworks like TensorFlow. To be specific, the Keras part of TensorFlow, because Keras provides us with the layers and models that we need to create. Let's run this part. Then the next part, as you can see, is loading the MNIST dataset. It is already available in the datasets of Keras, and just by using this code, you can directly upload the MNIST dataset into the Google Colab. Often when we talk about grayscale images, because this dataset contains grayscale images, we often use the normalization process also of reducing the range of the pixel values of these images. So in grayscale images, values vary between 0 to 255, 0 representing black, 255 representing white, and all the pixel values vary in this range. To normalize them or to bring them down in the range 0 and 1, we divide each of the image with the value 255 so that they are normalized, and now the values are in the range 0 and 1. So normalization of images like this, especially in grayscale images setting, is very common. Next is we need to reshape the images in a certain form so that they can be supplied to the convolutional neural network. For that, we are using the reshape function, and you can also check this structure. The first here, value 60,000, represents the number of images. Then we have 28 and 28 representing that it is a 20 by 28 pixel image. And the last one here is 1 representing that it has only one channel. Means it is not a colored image. It doesn't have the R and G and B values, RGB values or colored images. They are called 3-channel images. But since it is a grayscale image, it has only one value per pixel, representing either it is white or it is black or it has some shade of gray. The same reshaping we are applying to the test set also. Here, rest of the things are same. Only the number of images are different, which are 10,000 in this case. Let's try to view a few images also. So using Matplotlib, we can view a few images here. So the first image is handwritten image of 5. So the corresponding class is also 5. This is second image is 0 handwritten image. The corresponding class is 0, and so on. So our data set actually contains these images and their labels also. What is this handwritten image, whether it is a 5, 9, 6, 7 or others. Now we will try to create the CNN model, but you will see that we are not pre-processing the images and we are not stretching them out in the form of a vector. We will supply the images directly. Using Keras, we can mention these layers. So let's discuss them one by one. Often we use the sequential types of model. Sequential means that layers are arranged in sequence. We have seen that in the presentation also. And the input of one layer comes from its previous layer, and the output for the layer becomes the input for the next layer. So there is a sequence of layers. This is what is being represented with the word sequential here. Then the next step is mentioning the layers in order. So the first layer that we are adding here is a convolutional layer, convolution 2D to be specific, because our image is a 2D image in the end. It has many arguments. First argument is how many kernels or filters you want to apply on that image. Right now we are applying 32 filters on that. The size of each filter is 3 by 3. The activation function that will be applied afterwards would be a ReLU activation function. And we are also mentioning what is the input shape of the image. As you know, it is 20 by 20 image and it has only one channel since it is a grayscale image. In the case of colored, the last value would be 3 in place of 1. So we have, using this, we have added one convolutional layer successfully with 32 kernels, with each kernel of size 3 by 3. Then we have the max pooling layer of shape 2 by 2, which means it will consider out of the whole image, it will consider a grid of 2 by 2 and will consider the maximum value in that 2 by 2 grid, and it does that for all the grids that are there in the image. Then you can consider these two as first convolutional block. Then we are adding one more convolutional block with this time number of kernels are 64, kernel size is 3 by 3, activation is ReLU. Once again we are applying the one max pooling layer here. Once again we are applying one more convolutional layer here with 64 kernels and 3 by 3 kernel size. And then before doing the final predictions, we will flatten them out, because convolutional layers, they give their type or their size is usually multi-dimensional. So we will flatten them out in the form of a vector so that they can be applied to the fully connected layer or dense layer. So before going into the final fully connected layer, we have put one more dense layer before it, which has 64 neurons, and the activation function we are using ReLU. Finally, we have the last layer, dense layer or fully connected layer, which will make the predictions. We will make the predictions at this layer actually. That's why its size is 10. It has 10 neurons, and each neuron represents one specific digit, and the activation function is softmax activation function. Now we can create such a model and it should run fine. But the obvious question is how we design or come up with this specific configuration, and this is where the expertise come in. This is where the trying of many configuration comes in. So there is no hard and fast rule for the same, but we refer to the previous models that have been created by the expert and researchers. We take some insight from them, we apply our own knowledge on that depending and application specific knowledge, and then we usually come up with these configuration. So this specific configuration might work for handwritten digit recognitions problem, but may not work for other image classification problems. But let's say once we have created it, the next part is compiling and then training the model. For the compilation part, the optimizer or optimization algorithm I'm using is ADAM. Is a very popular optimization algorithm in the era of deep learning. We are using the sparse categorical cross entropy loss function, and we are using accuracy as the metric here. And we can use other matrices also like precision and recall, and we can use actually other loss functions also. For multi-class classification problems, sparse categorical cross entropy and simply categorical cross entropy are very common. There is a difference between them. Actually, categorical cross entropy, they are used for one hot encoding representation, so I will not go into that detail, but both of these measures or loss functions are very common. Once we do that, then we will finally supply the training images to our model. So we will supply the images. You can consider them as the independent variables, then the corresponding labels as dependent variables. The batch size means when the weight is going to be updated. So after 32 iterations, weights of the neural networks will be updated. Epochs, we will repeat this whole process, or max iterations is 5, so we will repeat this whole process 5 times. And here we are also using a validation set with the parameter validation split being 0.1, which represents that 10% of the training data set will be considered as a validation set. Now once again, when we run this, it will take some time, so I will not run this right now. I already ran it and you can check out the results. It goes epoch by epoch. It calculates values like loss, what is the loss, what is the accuracy on training data set, then what is the loss and accuracy on validation data set. So you can check them one epoch after the other. Once this training is done of 5 epochs, we can evaluate our model by giving it the unseen test input and the corresponding labels. It turns out when we do that, then the test accuracy turns out to be around 99%. So if we compare that with the traditional approach, if you remember, there the test accuracy was 97.5%. But in this case, in the case of convolutional neural network, the accuracy is 99%. And this gap becomes more as the complexity of the problem becomes huge. It is very difficult to identify the pattern in the input images. MNIST is considered a relatively easier data. That's why even though there is a difference in accuracy, but still the performance is somewhat comparable. But as the complexity of the problem increases, deep learning surpasses the traditional approach of doing the classification with a very big margin, in fact. Once we have calculated the accuracy on testing dataset, we can do other type of performance measures calculation also, like confusion matrix, precision, and so on. There is certain code for the same. We have inbuilt functions for confusion matrix and rest of them also. And when you will run it, we can generate actually the similar confusion matrix as we did earlier. And we can also calculate precision recall. You can see that their values are also better than as they were in the case of the traditional way of calculating or doing the image classification task. So now we have discussed both the ways how image classification can be treated in the traditional machine learning paradigm and how they can be solved using more advanced deep learning architectures, to be specific convolutional neural networks. In the next lecture, now we will focus on a different type of problem called text classification, and we will see how the traditional approach once again and the deep learning approaches can be used for that task. Thank you.